In this lecture, we look at functions defined by equations. Many functions we explore in mathematics and science are defined by an equation. We can define a function implicitly in an equation involving two variables. For example, does the equation 2x plus 3y minus 4 equals 0 define a function with presumably inputs x and outputs y? We can isolate y to get 3y equals 4 minus 2x, and then we can divide both sides by 3, and so y is 1/3 times the quantity 4 minus 2x, and so we now have explicitly solved for the output y. So yes, this is a function, and in fact we can write out f of x is 1/3 times 4 minus 2x. This explains how the input x turns into the output y. So yes, this equation, implicit equation, does indeed define a function. When we considered the equation 2x plus 3y minus 4 equals 0, we decided that the letter x would be an input and the letter y would represent outputs. That is tradition, but it's an arbitrary choice. We could have decided, contrary to custom, that y was the input and x is the output. Then, solving for x, we would have 2x is 4 minus 3y, and dividing both sides by 2, we would have that x is 1/2 times the quantity 4 minus 3y, and so we'd create a different function, g of y, which is 1/2 4 minus 3y. This would tell us how to input y and get output x. But most of the time we will stick to convention, and unless stated otherwise, we're going to assume that x is the input variable and that y is the output variable. The input variable x is often called the independent variable, and the output variable, y, is the dependent variable because the output variable depends on that input. Some worked exercises. Here's an equation, x squared y equals 4. Does that define y as a function of x? And if it does, let's write out the domain. We can attempt to solve for y. We can do that by multiplying both sides of the equation by 1 over x squared, as long as x is not 0, and this gives us that y equals 4 over x squared. This is indeed a function. We have solved for y in terms of the input x. Is there a problem with x being 0? No, if we go back to the original equation at the top, x squared y equals 4, x is not possibly 0 there. There's no way that x could be 0 and solve this equation, so x will never be 0 in this equation, and that's in some sense reflected by our function. Yes, this is a function. In fact, explicitly, y is 4 over the input squared. The domain of this function is all real numbers except 0. In interval notation, that would be the union of two intervals. The interval on the left, minus infinity to 0, will be all real numbers less than 0. And the interval on the right, 0 to infinity, represents all real numbers bigger than 0. Here's another problem. Does the equation xy squared equals 4 define y as a function of x? If we attempt to solve for y, we can, as we did before, multiply both sides by something, in this case 1 over x, as long as x is not 0. And so y squared is 4 over x, but I still have to find y. Y could be positive or negative. There will generally be two choices here. Y could be positive or y could be negative, and we're given no guidance on which to choose. The appearance of two answers in this problem violates the uniqueness requirement in our outputs for a function. So no, this is not a function. For example, if x is 1, then y squared equals 4 would allow y squared to be 4, so y could be 2 or minus 2, and we don't know which output to choose. Not a function. Here's another problem. Does the equation x squared y equals 0 define y as a function of x? Why not? It might be tempting to solve for y here, but first notice that x equals 0 could solve this problem. If x is equal to 0, then we can find y values that will make this be true. In fact, y could be 0 or 1 or 2.71828. Y could be anything. The input x equals 0 does not give a unique output, so this is not a function. No, not a function. Reasoning, if x is 0, then y could be anything. This is different from problem 1. In the first problem, we cannot even allow x to be 0 because it didn't solve the problem, didn't solve the equation. But here, x equals 0 does solve the equation, but it allows an infinite possibilities for the output. And all we need to run a function is to violate the uniqueness once. Let's practice the function notation f of x. A formula for f of x will tell us how to input x into my function. In this case, f of x is x squared minus 9, and we'll ask what happens when you toss 0 into the function. That's what we mean by f of 0. What happens when we toss 1 into the function? What happens when we toss minus 1 into the function, or input minus 5, or input minus x? If we input 0, then f of 0 will be 0 squared minus 9, which is minus 9. My function f of x equals x squared minus 9 means that anything you input, you then square and subtract 9 from it. If you input 1, you square it, subtract 9, and get minus 8. If you input minus 1, you square it, subtract 9, and again get minus 8, because minus 1 squared is just positive 1. If you drop minus 5 into our function machine, you square minus 5 and subtract 9. 25 minus 9 is 16. If you drop minus x into your function, you square minus x, which is x squared. Then you subtract 9, and you get x squared minus 9. So here are 5 examples of the function notation. Let's look at some more complicated examples. Same function. Let's compute f of x plus h, f of square root of x, f of 2a plus 1, and then finally minus f of x plus 2. In the first case, if my function squares inputs and subtracts 9, then when you drop in x plus h, you have to square x plus h and subtract 9. Take some algebra to square x plus h. X plus h squared is x squared plus 2xh plus h squared. Then we subtract 9 and get this answer. Don't forget that when we square x plus h, we're going to get a middle term 2xh. X plus h squared is x squared plus 2xh plus h squared. What if we drop in the square root of x? We square it and subtract 9 and get x minus 9. If we drop in 2a plus 1, we square 2a plus 1 and subtract 9. Our algebra leads us to this. And finally, what does the expression minus f of x plus 2 mean? It's equal to minus x squared minus 9 plus 2, or minus x squared plus 11. In the next presentation, we find the domain of functions.